Alright, let's talk about the inverse tangent function, also known as arctangent or arctan. But I want to talk about first what an inverse function is in general, and also what the original tangent function is, which I think will make all of this make more sense. Um, and then first, let me just mention that the purpose of the arctangent function is figuring out um, unknown angles, or that can be a major purpose, which is what we'll use it for in some real examples down here. So that's where we're going for this, and so yeah, let's just actually review first what tangent is, and actually what all of trigonometry is. Trigonometry is just the study of the relationship between angles and the ratios of sides with respect to those angles. For example, tangent, the tangent of an angle is, so we've got this right triangle here. The tangent of this angle is the ratio of the length of the side opposite it, over um, this, the length of the side adjacent to it. So that ratio of the opposite to the adjacent. Um, you might have learned the mnemonic SOHCAHTOA. So we're talking about TOA. The tangent is opposite over adjacent. It's the ratio of the opposite side to the adjacent side. Um, the adjacent side to an angle is the side that's next to the angle that's not the hypotenuse. The hypotenuse is that special side that's across from the 90-degree angle. And then the opposite side is just kind of what it sounds like. If you take, I always imagine like an arrow like this. If I'm considering this angle, the side opposite to it is you just kind of shoot an arrow straight across. That's the opposite side. All right, so the tangent is just the ratio of the side opposite the angle to the side adjacent to it. Um, and okay, and then let's talk about what an inverse function is, and then we'll talk about what the inverse tangent is. An inverse function, quote unquote, undoes another function. It's the simplest way to look at it. So my favorite example, because it's so simple, is just the square function and the square root function. Um, I can square the number 5. So I'm starting with the number 5. I can square it, and that's 25, which means that I can square root the number 25, and and that's 5. Okay, so you see we went from um, 5, squared it, and then square rooted it, and we ended up back at the number 5. So the square function and square root functions are inverses of each other. They undo each other. Um, so tangent and the inverse tangent, or also known as arctangent, are like that. So if the tangent of an angle is the ratio of the side opposite to it to the side adjacent to it, then the arctangent of that ratio of the opposite to adjacent is that original angle. For example, so I've got this little chart here of common trig ratios for these basic angles, 0 degrees, 30 degrees. So for example, the tangent of a 45-degree angle is 1, or you can think of it as 1 over 1. The ratio of the side opposite to it versus the side adjacent to it is 1 over 1. Well, that means that if I take the arctangent of 1, uh, the answer is 45 degrees. Okay. Well, let's just get into these concrete examples. Um, okay, so suppose I need to figure out what angle this is, and what I know is the length of the side opposite to it. I know that it's part of a right triangle, so we can use these trig ratios, trig functions, and I know the length of the side adjacent to it. So I know that the tangent of theta is equal to, so the ratio of the opposite to the adjacent is, so it's square root 3 over 3. That's the tangent of theta degrees. So if I take the arctangent of um, square root of 3 over 3, that'll tell me what theta is. Okay? So let's check out the chart. Once you kind of get into the unit circle and have these memorized, and it's, it's not easy to memorize in a chart like this, but on the unit circle it makes sense. There's these patterns of like 1 2 3 3 2 1 and stuff like that. So once you have these memorized, these basic trig ratios for 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, and then multiples of those, you won't even need a calculator to calculate the arctangent of some ratios. So let's check our chart first, and if we don't have this ratio in the chart, then we just grab the calculator. So square root of 3 over 3, right there. So the tangent of 30 degree angle is the ratio of square root of 3 over 3. Therefore, the arctangent of square root of 3 over 3 is 30 degrees. So our answer is 30 degrees. So let's try another one here. Looking at this theta, it's different theta. We want to know, well, what is this angle measurement? Well, what we're given is that it's a right triangle. We know the adjacent side, and we know the opposite side. So we know that the tangent of theta is that ratio, opposite over adjacent, opposite over adjacent. So what's the arctangent of 2 square root 3 of 6? Well, is this on our chart? 2 square root 3 over 6. We don't have that, so we could just grab the calculator and do it. Or we could realize that we can just reduce this ratio, right? 2 and 6 have a common factor, which is 2. So I could make that a 1, and I can make that a 3. In other words, 2/6 is equivalent to 1/3. So 1 times square root of 3 over 3. Well, that's just square root of 3 over 3. So actually, this is the same angle as this one. It's 30 degrees. So this triangle is actually similar to this triangle. It's proportional. Hence, that's why this is 30 degrees. So look for ways in which you can reduce ratios into one of these standard one of these standard ones. Worst case scenario, though, you can always just grab the calculator, unless the kind of limitations of whatever test is coming up is you can't use your calculator. Then you should really work on memorizing these simple ratios. Look for patterns. See how it goes. 1 2 3, 2 2 2, 3 2 1, 2 2 2. Yeah. Okay. Let's try one more here, and I'll let you do these examples. So we know that. So we've got the opposite and adjacent of this particular angle. So that we know that the tangent of theta is 1 over 9. So what's the arctangent of 1 over 9? That'll tell us what theta is. 1 over 9 is not one of these ratios. So I can just, 1 over 9 is 0.111 repeating. So in other words, the tangent of theta is 0.111 repeating. So we could take the arctangent of that decimal. And actually, I'm just going to, was it 1 over 9? Yeah. I'll just take the arctangent of that fraction. So yeah, you should have maybe it's called atan, Maybe it's called arctan. Maybe it's called the button might be tan with a -1. It's inverse tangent. So look for that. I'm going to put my calculator in degrees mode so it gives me the angle in degrees, not radians. So that angle is about a 6.3 degree angle. It's kind of a tiny angle, 6 degree angle. All right, so here's some examples for you to try. Use the arctangent function to find the original angle. All right, all the best. Take care.